The universe has come a long way since pun intended. However, the most fantastic story of all time is not completely understandable even to those who have read it. More so in the early chapters, written in history during the first 2 to 300 million years of the universe's 13.8 billion year existence. The James Webb Space Telescope could be the deciding factor. The observatory can look 3 times as far back in time as the iconic Hubble Space Telescope. The Webb will detect infrared wavelengths long enough to penetrate the dense smog of all the light and dust between Earth and the farthest galactic poles, revealing information about the ancient universe where these wavelengths began their journey through space billions of years ago. Hello everyone, welcome to another exciting video from our channel. In today's video, we will discuss how the James Webb Telescope unlocks terrifying secrets of the universe. But first, subscribe to our channel and click the bell icon to never miss another video from us. That being said, let's get this started. Despite the fact that it is not yet ready for data collection, the Webb telescope promises a level of perceptions made possible by its 4 instruments. These instruments can work in tandem to siphon observations of objects such as galaxies, maximizing telescope efficiency. NASA announced on March 17 that the Webb Space Telescope has begun a new phase of its preparations to look deep into space and time, a 6-week procedure known as multi-instrument multi-field alignment. This procedure will aid in ensuring that all 4 of its science instruments are operational by the summer of this year. The procedure is a critical next step after Webb's most recent triumph, producing the mission's first focus image of a star, which NASA released on March 11. The image was created by carefully aligning all of Webb's 18 mirror segments to work as a single unit, a process that is still ongoing. According to Webb Deputy Senior Project Scientist Jonathan Gardner, we lined them up so that we could have a perfectly focused image on one of our 4 cameras, Gardner says. But now we need to change that alignment so that it's perfect across the entire field of view of all 4 instruments. Following the current alignment process, 2 months will be spent revising the various filters and modes of all 4 cameras on the telescope. Finally, the mission's first scientific images will be released in the summer, bringing the preparations to a close. Gardner anticipates that these will be available by mid-July 2022. What will be detected by the Webb? Early galaxies will be one of Webb's primary research areas. These celestial bodies serves as a beacon for scientists studying the early universe. Because Webb allows scientists to operate multiple instruments at once, it can collect more precious drops of distantly emanating galactic light from these distant lanterns. Roger Wildhorse, an interdisciplinary scientist at Webb, explains how it works. As a stand-in for Webb's field of view, consider a full circular pineapple slice with a hole in the middle. Windhorse claimed that 2 of the 4 operational instruments can observe the sky at the same time within that field of view. Collecting data from 2 instruments at the same time allows scientists to learn twice as much about the distant universe in a single window of time. For example, suppose someone takes a photograph of 2 different, non-adjacent regions of the early universe using the same filter, only 1 shot, but twice as much data. You must plan it to ensure that the data is useful, but if you plan it correctly, you effectively double the data. As a result, we can observe twice as efficiently, Windhorse says. This could be especially useful for deep field surveys, which look at a single field of view for an extended period of time in order to collect as much data as possible for scientists to sift through. One of Webb's predecessors' most significant achievements was the Hubble Ultra Deep Field. Hubble spent 592 hours creating that iconic cosmic landscape. Webb, according to Windhorse, could take only 30 hours. The parallel capability sort of comes with the design of the telescope. Gardner, a Webb scientist, explains. However, in order to collect any kind of data, the 4 instruments must be lined up so that the images in those instruments are sharp, and that is the process we are currently in. According to Windhorse, Webb's near-infrared camera and near-infrared imager and slitless spectrograph work extremely well together because they are similar instruments and the data from one complements the data from the others. Explanations of galactic evolutions by the Webb. Another important reason why this approach is beneficial is that the statistical analysis of galaxies aids in our understanding of their evolution. Galaxies are cosmic islands where matter, dark matter, and light are concentrated. The stars and planets that form the first galaxies may have done so quickly enough in some places to produce supermassive black holes which are now found at the center of almost every galaxy observed. Webb's amazing eyes will frequently target galaxies from the first few million years of the universe. Galaxies on the edge of Hubble's capabilities that can bring researchers one step closer to understanding why the universe appears the way it does today. It's a number game because galaxies over enormously long timescales of millions and billions of years. It is impossible to observe a single galaxy's changes in real time. Cosmologists studying the evolutions of these structures cannot approach their research in the same way that a horticulturist can study the transformations of a single plant. With galaxies, we need to look at the most distant galaxies to see how galaxies form. And then, we need to look at less distant galaxies to see how average properties change over time. We can make a one-to-one comparison, Gartner says. Deep field surveys are conducted by scientists in order to detect these slow changes. Parallel data collection increases the number of similarly aged galaxies that can be studied in different ways at the same time, revealing more about a specific chapter in the universe's history. Aside from the primary target, Webb's instruments could collect data on older or younger galaxies. This provides data on various evolutionary stages that would otherwise go unnoticed. It's similar to archaeology or paleontology in that as you dig deeper, you may see older and older layers, but you're not seeing the same things, Gartner explains. What about the Webb telescope makes it so powerful? It includes the 6.4-meter diameter primary mirror. It has made of 18 tiny sections that must all be perfectly aligned. The segments are encased in a gold coating that is 1,000 times thinner than a single strand of human hair. 24-karat gold reflects infrared light more effectively than other metals. Infrared wavelengths are slightly beyond what humans can see in the visible spectrum. The mirrors are made of beryllium rather than solid gold. To function correctly, the Webb telescope must be kelp-coated. It achieves this by employing a 5-layer sun shield the size of a tennis court. This mechanism was folded up when Webb launched on Christmas Day, but less than 2 weeks later, the shield's extremely thin layers were successfully released. The sun's immense heat would overwhelm the telescope sensor if the barrier were not present. The side facing the sun will be around 260 degrees Fahrenheit, while the other side will be around 370 degrees below zero, a difference of around 600 degrees. Thanks to the sun shield, Webb has a sun protection factor of 1 million. One of the concerns scientists have regarding the Webb telescope is that they will be unable to repair any faults that arise during the launch and operation. In comparison, 5 space shuttle crews have visited Hubble over the course of its life to correct the telescope's coefficients and perform maintenance and upgrades. However, this is due to the Hubble Space Telescope being only 340 miles away. The Webb telescope is approximately 1 million kilometers away. This is much beyond the scope of spacewalking repair teams. As a result, NASA only gets one shot at doing it right. If the appropriate technology is developed, scientists may be able to send a robot to review Webb, thereby extending its life. NASA had anticipated that the telescope would only last 10 years, but thanks to an efficient launch, there's enough fuel left to power the JWST for the next 20 years. For the time being, scientists are waiting for Webb's first photo, which are scheduled to be released this summer. After that, the JWST will begin to work. It will help with the examinations of the nature of dark energy in the universe, as well as the comprehensions of these very old materials. It will also help in the search for another Earth among the thousands of distant exoplanets scattered around the universe. Surprisingly, the JWST began demonstrating its worth nearly $10 billion even before the first photographs were taken. Northrop Grumman, who created the telescope's mirrors, had to break new grounds because a precise mirror had never been manufactured. The company's technology is currently being used by eye surgeons. They were also involved in computer-related projects. And with that, we have reached to the end of the video. Thank you for tuning in. If you like this video, please like, share, and subscribe to our channel for more fun videos and the latest informations. We look forward to seeing you in the future videos.